My name is Austin Gresham, and I am an Enterprise Transformation Executive with Round Tower Technologies. This presentation is Enterprise Transformation and very specifically the four pillars of Enterprise Transformation that Round Tower uses to enable our customers to embark upon a digital transformation journey. For those that don't know me, I've been with Round Tower for about 5 years. I currently lead enterprise transformations for Round Tower's North region, spanning from Kentucky all the way through New York City. I've been in the industry for over 25 years now and held various roles, which gives me a unique perspective all the way from engineering and architecture down to operations, even application development, and then all the way up to the C-level through strategy. I want to start with a discussion really to sort of set the stage for why it is that we're having these conversations now around digital transformation and what it means when people say we've got to go faster or you need agility or you need to outpace your competition. We hear all these things frequently, but I want to put it in some context. And I'll start with a discussion around what we call, or what's being called, the four industrial revolutions. So this is a little bit of a history lesson, but again, to put this in some context. These four industrial revolutions have a number of things in common. We are right now in what is referred to as the fourth industrial revolution, which started roughly 4 years ago, depending on which industry analyst you speak to. But suffice it to say, we are in the early stages of the digital revolution. The four things that each of these revolutions had in common, going all the way back to the 1700s, was that each of these were started or predicated on the introduction of some new technology that no one knew about up until that point. It's hard to imagine that steam was thought of as a new technology, or electricity for that matter, but each of these four, all the way up through computers and digital, was denoted by some type of technology. And the second thing that each of these have in common is because there were new technologies for each of these four revolutions, there were consultants that were brought in to help businesses understand how to apply these new and misunderstood technologies to their business. Again, it's hard to believe that people didn't understand how to use electricity 150 years ago, but that was the case. And if you compare that with today, there are many, many consultants out there with things like cloud computing, with blockchain, with augmented reality, digital reality, with IoT and machine learning. Lots of consultants out there because right now in this digital revolution, there are very few standards and very few proven methodologies and technologies that have kind of withstood the test of time. So the market is still in pretty tremendous flux. The third thing that each of these have in common, again, consultants were brought in to help people adopt these technologies, but there were winners and losers in each of these revolutions. The losers were the ones that took these new technologies and simply bolted them on to their existing businesses. So if you go back to the days of electricity, at that time, most factories were running on steam engines, and some people adopted electricity, and they literally took the giant steam engine that was running their factory and bolted on this brand new, shiny electric motor to run the factory instead. And if you know anything about how factories were designed a few hundred years ago, basically there was this common shaft that ran the entire length of the factory, and off of that shaft were pulleys and gears and levers and these very complicated systems that ran each of the individual workstations throughout the factory or the assembly line. And these factories were really, really unsafe. There were very often deaths, dismemberments, disfigurements, people getting their arms caught in these pulleys, all kinds of awful things right out of the scene of a common modern day horror movie. But the people that took electricity and realized that they could do something fundamentally different, they did things like broke down the factory into a series of connected workstations, all driven by their own individual electric motors rather than the one big electric motor running the whole factory. And this did a few different things. The first thing it did was it made those factories much, much safer. It made them much, much cleaner. And now, because of those two factors, people wanted to go to work for these companies. If you were left with the choice of the old industrial factory where you could get hurt, or this new one where you could dress in nice clothes and not go home at the end of the day, covered in oil or something else, you were going to choose the new one. The other thing that they realized is that by breaking down the electric motor into multiple tiny motors, they also reduced their failure domains. So now if one of those little electric motors breaks down, only one workstation, maybe a couple, are affected, rather than the giant electric motor that when it breaks, the entire factory is offline. So they got some real business benefits out of that, as well as the cost to repair one of these small electric motors was much cheaper than fixing the big one. So again, the people that realized that changing their business model with these technologies came out the winners. You couple this with today's technologies like cloud computing. Simply taking cloud computing and bolting it onto IT doesn't really solve a problem. It just moves that problem to a different place. And then the last thing that each of these have in common, which is really probably the most important thing on this slide, and it's actually a commonality but sort of a paradox, is that the rate of technological adoption throughout each of these four revolutions increases exponentially as you move toward today. So if you look at the steam era, it took about 100 years for people to really adopt those technologies. Electricity was about half of that. Computerization starting in the 60s was about half of that again. But if you look at today's technologies, if we put the stake in the ground that we started the digital revolution around 2015, that's only 5 years ago. And you can already see major companies that are dominating the industry today using digital technologies. So that rate of adoption is kind of hard to picture. But this graph sort of puts it in perspective for you. If you look at the rate of adoption in the upper left, the first 100 years with steam, you can see that, about 2/3 of the way through, we get sort of the beginning of that hockey stick curve. So in that first 100 years of steam, there was about a 1,000-fold improvement in the adoption of technology. If you go down to the bottom left and you put that in perspective of 200 years, so right up to the beginning of the computer era in the 1960s, you see the hockey stick is a little more pronounced. That's about a 1,000,000-fold increase in technological adoption. And you notice that the first 100 years don't even register as a blip on this graph, although it's about halfway through this one. On the far right, you see the entire last 260 years of technological adoption put in one graph. So this is the beginning of steam up until roughly today. The hockey stick curve really looks like a hockey stick. And you see that rate of change is unbelievable. The amount of growth on this graph represents a 97 million-fold increase in the adoption of technology. And again, you'll notice that the first two graphs, the 100 and the 200 years, don't even appear on this. This is really hard for the human brain to comprehend. We're very, very good at linear math and linear projections. If today is 1, tomorrow is 2, the next day is 3, and so on. We're really not good at this exponential math and really recognizing it. And that's why the title of this slide is chessboard growth. This goes back to the old story of the king who challenged the peasant to a game of chess. The peasant won, and for payment, he asked for 1 grain of rice to be put on the first square, 2 on the second, 4 on the third, 8 on the fourth, and so on. And the king gladly said yes, thinking that was a no-brainer, not realizing that by the time you got to the 64th square on the chessboard, you were in the billions of grains of rice, which was more than the GDP of the entire world at the time this story supposedly happened. There's a man by the name of Ray Kurzweil who's been in the industry for many, many years. He coined the term the second half of the chessboard, which is where we're approaching now. So the rate of change is unbelievable. So when you have business leaders faced with this rate of technological change, and they're asking IT to move faster, to be more agile, to outpace the competition, this is why. So keep this graph in mind as we move throughout the presentation, because I'll reference this a couple more times to put this in perspective. So how is it exactly that we are accelerating so rapidly? And the reason is basically this compounding effect of technologies, what I call springboard technologies or paradigms. And the first one is Moore's Law. And that's the idea that we're roughly doubling the amount of transistors within the same square inch. We're reducing costs by roughly half. So we're doubling computing power every 18 to 24 months. And without that rate of acceleration, we wouldn't have things like the smartphone and the Mac laptop and the iPad and all these other technological advancements. So that's the first one that sort of predicates all of these others. The other springboard technology is the global internet. Back in the 90s, we practically covered the earth in fiber optic cable because of the dot-com boom. In the early 2000s, we got the bust. And because of that, these companies that remained that bought up all of this fiber for pennies on the dollar now have global networking that's practically free. If you think about now, on your smartphone, you can access the web on your phone via the global internet to China, to Germany, to Australia. Think of the furthest reaches of the planet. You can get to it for largely no money at all. The third one is cloud computing, and I have an asterisk next to cloud. Thomas Friedman, who's another famous author, he refers to cloud computing as the supernova because cloud really doesn't do it justice when you think about what the effects cloud computing have had on society and technology. But cloud computing wouldn't be possible without the global internet and Moore's law before it. And then we move into smartphones. And again, smartphones wouldn't be possible without Moore's law and the global internet. And largely because of cloud computing, things like the App Store and web-based apps wouldn't exist without those other technologies. So if you put these four together, they've springboarded onto each other. And if you think about a technology like Uber as an example, without these four springboards, a technology like Uber wouldn't be possible. It wouldn't be financially feasible because if you didn't have the internet and the cloud and smartphones, you, as a designer of Uber, would have to create your entire global networking that everybody, every one of your customers could get to so they can get to your services. You would have to create some type of device that would be ubiquitous that everyone would have and be able to access your services. You would have to create your own global payments system, cross currencies, cross borders, US dollars to euros, those types of things, a platform of trust. You would have to create your own logistics and mapping platform, things like Google Maps. So no one would have invented that from scratch 20 years ago. It would be literally impossible to do. But if you look at these springboard technologies, it allows someone like Uber to build that type of global platform in relatively speaking terms, very cost effectively. So knowing that, if you look at those springboard technologies, what they're all enabling is for all of us, all enterprises and small businesses, to basically become data companies. If you look out at the companies that are dominating the industry today, they are using data as the competitive advantage. So think about the private data that belongs to your organization that no one else has. That is now your competitive advantage. In the prior industrial revolutions, your competitive advantage was a couple things. In the agrarian economy, prior to the Industrial Revolution, it was land. The more land you owned guaranteed your probability of success in the agriculture market. When we moved into the Industrial Revolution, it was all about capital. The ability to purchase infrastructure and goods and services pretty much guaranteed your dominance of the market. In today's economy, there are two things that matter. It is data and it's people. We are now in a service-based economy, and those two things make the difference. I'm not going to talk about the people side. That's a whole different conversation with lots of fields of study, but I will talk about the data part of that. So if we know that we need to become a data company, we see this adoption curve and this rate of technological change coming at us very rapidly. Why is it that everyone just hasn't transformed into a data company? And there's a handful of reasons for that. No matter which industry analyst you subscribe to, Gartner, Forrester, IDC, Deloitte, Accenture, they all point to the same handful of reasons why transformations are difficult. And the first one, the most difficult piece of any transformation, is culture. And culture, in a nutshell, is made up of the people that are part of your organization, the people that you hire, the people that lead your organization, everything in between. And most of these corporate cultures were built on this prior three industrial revolution hierarchy, right? It's very rigid. There are org charts with very firm, established relationships between management and people below. So those cultures are rigid and they're really averse to change. And they're really averse to risk, especially the well-established companies, very specifically in the Midwest where I do a lot of work. These companies are just not willing to change. They know that what's worked for them for the past 20 years, they hope will work for them in the coming 20 years. The second reason why transformation is difficult is because of prioritization. I also equate this loosely with budget. If you're a line worker at a company, an individual contributor, and you're given the task of transforming from the executive team, but your bonus is still aligned with producing so many widgets or getting so many lines of code out the door, you don't have the incentive to devote any time to transformation, let alone budget. If they say, go do this transformation thing, but don't give you the budget to go do it, you're at a loss with how to actually go transform. So without that prioritization from a compensation side, from a time and energy and an innovation side, it's very difficult to transform. And most people are very familiar with this one, talent and skills. You have people that are used to operating in a particular model. They need to be retrained to operate in this new digital realm. In the IT world, you have server and network and storage administrators. In the cloud world, as an example, those roles blend together. If you're modernizing your data center, you probably don't have separate storage, networking, and servers anymore. Everything is software defined. That requires new skills. If you're trying to become a data company, you need data scientists, you need data engineers, you need business people with data science acumen to be able to help you uncover the problems that you're going to try and solve with data. So it's very hard to find this, and there is a shortage of talent for these skills. The other one is technology-driven investment decisions, and this is the new shiny object syndrome, as I like to call it. This is buying technology for the sake of technology without really understanding the business implications and impact in those technologies. So what you end up with at the end of the rainbow is a bunch of investments in a bunch of different technologies, none of them providing business value. So that's an expensive proposition. And the last one, frankly, is your architecture and your infrastructure. If you're in an IT organization today and you're still running an IT shop that looks like this graphic, you are in trouble. And again, to put it in context of that acceleration curve, if your company has to wait weeks or months to get IT services delivered to the business, you're in trouble. You're going to lose to your competition. We've all probably heard the term shadow IT, which was coined in the mid-2000s. And this was right at the advent of public cloud, where business users and developers were going to the Amazons of the world and buying infrastructure services with their credit card so they could go develop this new app or get access to this data they didn't have before. And at first that was really irritating to IT departments because they were supposed to be the ones supplying these services. So they were angry about it. There was a lot of friction between the business and IT. Make no mistake, this wasn't necessarily a good thing because now those cloud assets are outside of your governance and your security controls. So this wasn't a good place to be. When IT realized that they were the initial cause of this problem, that's when cloud computing started to be adopted more ubiquitously and within the folds of IT. So that model needs to be brought forward so that you can deliver services to the business more rapidly so that they can keep up with that curve that we talked about earlier. So when you're talking to the business, you have to talk in terms that the business understands. And really, any for-profit business is interested most in one metric, and that is profit and revenue, which maybe is two metrics. But the idea is you need to increase your revenue, your top-line revenue, and you need to decrease the cost of selling that service or good to increase your profit. On the right-hand side, we have basically 6 metrics that directly drive profit and revenue. Increasing your market share, which is your customers, drives top-line revenue. Increasing your retention of existing customers and attracting new customers directly impacts revenue. Decreasing your time to market directly impacts revenue and also impacts the first two of market share and retention and attraction. On the cost side, you have to overall decrease the costs of running your business. And a couple ways to do that are increasing the efficiency of delivering that, which includes streamlining your processes, decreasing the risk of delivering it, and then across the board, decreasing the cost to deliver. There are 4 attributes of successful 21st century enterprises that drive those 7 business metrics. You can draw lines directly from each of these to those 7 business metrics. And the first one is being agile. This directly drives things like attracting new customers, increasing your market share, beating your competition, right? Being first to market. You have to act quick, and you have to be able to predict and react to changes in your market on the customer side, with your business partners, with your employees. Data-driven, we've talked about quite a bit. You have to prioritize the value of your company's private data. And I want to be very clear that it's not the algorithms that are the investment here. Algorithms are great because they help you drive insights from that data, but it's the data that is the intellectual property here, not the algorithms. Experience focused is hugely important. And again, it doesn't matter which industry analyst you speak to, focusing on the customer should be your number one priority in this whole digital revolution that we're in today. Studies show a couple things. One is that companies that are focused on customer experience outperform competitors on the S&P by an average of 80%. That's almost double. That's a significant impact on customer experience. The other one is about the employee experience. So it's not just customers, it's employees and business partners. Employees that are satisfied equate directly to increased revenue for companies. So when your employees are happier coming to work and doing their job, your company's going to make more money. And then lastly is innovation. This one we'll talk about a little bit more, how to actually break through this veil of innovation. But you have to have time and budget and energy to be looking at how you change how you're delivering IT to the business, what technologies that are on the horizon are relevant to the business. The business itself needs to be innovative, thinking of new revenue streams, again, using that private data to find new ways to serve customers and to make money ultimately. So the solution that Round Tower believes will solve these problems and allow you to address the 4 key attributes which drives the 7 business metrics are what we call the 4 pillars of enterprise transformation. And we believe that you have to coordinate a holistic strategy across these 4 pillars in a very methodical way to really drive change within the organization. The first one we'll talk about is cloud transformation. And this doesn't necessarily mean the adoption of public cloud. This doesn't mean you have to push everything to Amazon or Azure, but this could be, and very likely should be, part of your strategy. What cloud transformation is mainly about is simply changing the way that you deliver IT to the business. And you do that in a few ways by addressing, again, 4 other subdomains. And the first one is your operating model. And this isn't to be confused with the operations, like the people that carry the pagers. This is the people and process side of how you deliver IT. This is switching from siloed to cross-functional teams. This is changing the processes that you use. This is all about everything that you do to deliver those services. Not the technology, but everything that surrounds the technology. You have applications. You've got a business that you're running, and you have business services. Those business services today very likely run on some type of application, whether it's a CRM system or some custom app. You have basically 2 types of those applications. You have the cloud-native applications. These could be things like Salesforce or ServiceNow that are running as software as a service in the public cloud. But these could also be applications that were developed to be able to run on a public cloud service like Amazon or AWS, or Azure or AWS, or your own on-premises cloud like Pivotal Cloud Foundry or one of the other ones. But you also have legacy applications. And when I say legacy, I don't mean the old and busted and broke applications, although sometimes those are there too. But really what I mean is the applications that run your business, that are the core of your business. If you're a 30-year-old insurance company in the Midwest, you probably have a mainframe with a significant amount of legacy customer information on that mainframe. You have to find out what to do with those applications. If anything, they might just stay where they are. But you have to address both of those sides, the cloud native and the legacy. From a platform's perspective, this is sort of the infrastructure, if you want to call it that, platform as a service, infrastructure as a service. The bottom line is it needs to be scalable and it needs to be responsive. And when I say scalable, that doesn't just mean physically scalable, but it means financially scalable so that you're not purchasing infrastructure in giant 3 and 5 year chunks. You're doing it in a much more predictable and linear way and getting out of the 3 to 5 year buying cycle for your platforms. And then last but not least is security. And you'll notice that security doesn't have its own pillar within those broader 4 pillars. And that's because we believe that security should be woven into the fabric of everything that you do. It has to be holistic from an information security perspective and a application and infrastructure security perspective, governance, compliance, all those things. But it also has to be risk-based. It's not enough to just drop a firewall in front of a server farm and call it a day. You have to understand the value of the data that you're protecting, what the cost of that data is to your business, especially the private data that is your intellectual property. And you have to apply security to that based on the risk profile of the assets and information that you're protecting. Modern data center is meant to address mostly the infrastructure that stays within your 4 walls. You're probably always going to have some type of infrastructure that still sits within your data center, but you have to make sure that the infrastructure, the servers and all of that participate in this digital ecosystem. So it has to be software defined. Software defined everything. Software defined networking, software defined storage, servers, compute, all of it. The transition piece you can also think of as migrations. You have to rationalize what you have today. You have to rationalize your applications. You have to look for duplication of effort. You have to look for fit for purpose. Are these applications appropriate to live in a public cloud? And if so, why? Financially, technically, government's data sovereignty. There's a lot of levers to pull and knobs to turn when making those decisions. And then you also have to think about those legacy systems. If you have a mainframe in your environment that runs your core business, you can't just pick it up and move it to the public cloud. Even if technically it's feasible, it's very likely financially untenable. And so why not just use that legacy system that you've made significant investments in and make sure that it participates in this new digital ecosystem, this new modern data center? Again, security woven into the fabric of this. The big things here is that security is also software defined, policy driven, not physical firewalls and all those types of things, but policy driven based on the risk of what's being protected. And you need to change the way that your security operations operates in this new environment, because that will be a fundamental change as well. And then lastly, your operations, your tools and processes. This is very similar to the operating model. This is about operations, monitoring, keeping the lights on. How do you make sure that your operations are set up to properly operate and monitor this new modern data center coupled with this new mode of cloud in terms of how you're delivering IT? Automation is what I often refer to as the glue that brings all of this together. This is moving from manual, error-prone, and frankly mundane, not value-added tasks to automation that is standard and it's secure. And the first part of automation is the traditional infrastructure automation. This is configuration management. There's so many tools out there that can help you manage your infrastructure in what we call zero touch, so that when someone asks for an asset, let's say it's a server or an application to be provisioned, the entire process is automated and there's no one in the operations staff that's clicking a button or pulling a lever to make this happen. On the development side, if you're doing your own application development, taking advantage of continuous integration and continuous delivery, but that also implies the automation of the underlying infrastructure that supports those different levels. So from test dev to QA to production, automating that and making sure that dev and QA match production. You don't have the age-old problem of throwing it over the wall to the production people and doing the weekend rollout that no one loves. Automating the development lifecycle as well as the infrastructure underneath it is also critical. From a decision perspective, this is about using machine learning and AI with streaming analytics to do real-time analysis of your infrastructure. There's this concept of intelligent infrastructure now, which kind of in that same vein as zero touch implies that people don't have to have eyes on glass all the time and respond to every little incident. Why not let the machine respond in a way that allows those to remediate themselves? Turn off a server, move the apps to somewhere else, notify operations that this machine needs to be replaced, those types of things. But doing it in real time and not relying again on the human sitting in front of the console to do those tasks. And the last piece of automation, which is usually the one that people kind of freak out about the most, is process automation. This is front office, back office. The main technology here is robotic process automation. And this is about the mundane. I often ask the question when I give presentations on who in the audience enjoys cutting and pasting invoice numbers from PDFs in an email to a CRM system or an Excel spreadsheet. And usually no one's hands go up. This is the type of thing that you can automate. So you get rid of the mundane, really kind of crappy work that a lot of administrative staff have to do, or even customer service staff. Robotic process automation has been shown to increase customer satisfaction because now the customer service agent isn't busy clicking on the keyboard, typing in credit card numbers and switching between account screens. The RPA product is doing that, and the customer service agent is now free to focus on what they're really good at, which is human interaction and providing customer service. So this side of it is very, very critical. The last piece is the connected enterprise. And connected in our context has two different meanings. The first one is connectivity, which is the traditional networking. This is software-defined networking, software-defined wide area networking, edge computing, 5G, all the things that bring your infrastructure together. Again, as mentioned before, this has to be software-defined. It can't be port-based. It can't be manual. The other side of connected enterprise is connecting with people. So this is things like the digital workspace, collaboration and knowledge management, a little bit more of that human and machine workforce working together. I like to think of this as not Terminator, but more like Iron Man, right? Using the technology, having this personal robot assistant to make you better at what you do, not replacing what you do. Then there's the ecosystem. This is connecting with business partners, employees, customers. It used to be that the way that you would make money in our economy was you knew something that nobody else knew. You would patent that knowledge and you would bank on that 20-year patent and make money as long as you could, right? Pharmaceutical is a great example of that. You have a molecule that you develop to cure a certain disease. you patent that molecule, you deliver that, you make billions of dollars. Pharma companies are recognizing that they are actually better at working together. If the end goal is really to provide cures and medicines for people, this whole idea of hoarding your institutional knowledge is not acceptable anymore. So now pharmaceutical companies are partnering with other pharmaceutical companies to co-develop. You need technology to help you do that. You need to be connected in a very beneficial way, in a very meaningful way with other companies in order to pull this off. So that's what the ecosystem is about. And the last part is the data lifecycle. This is what you do with all of that data, how you collect it, what you collect, how you secure it, where you store it, who gets access to it, how you govern it, and then lastly, how do you actually derive meaning and value out of that data? It's not enough just to look at a chart with a bunch of graphs on it. What do you need to go do to actually affect a business outcome? So we think that you've got to put this together into a roadmap. This isn't something that you're going to do in a month or 6 months or even a year, but you have to have a methodology and a roadmap, somewhere that you're trying to get to in order to address all 4 pillars. And what we've come up with is this idea of modernize, optimize, and innovate. So it's this model for what we call self-funded transformation and innovation. And this is a high-level conceptual graph, but what you see is on the left, you start with modernizing your data center, moving into software-defined technologies. As you advance up the curve, moving into cloud-based, whether that's hybrid, multi, on-premises, layering on automation, your business as usual costs, that orange line, are going to continue to go up incrementally just based on inflation and other things. But we feel like along the way, if you can make actual financial gains by moving to, let's say, modern data center, so you've now created an infrastructure that's more efficient, that's more cost effective, that isn't, again, that 3 to 5 year burst of capital expenses. Over time, your actual run rate is going to go down. And not only is your financial outlay going to go down, the time needed by your staff to manage that infrastructure is going to go down as well. What you have to do to take advantage of this model is to partner with the business, especially someone like your CFO in your financial area, to take those savings that you derive each step of the way and reinvest those back into IT to enable you to take the next step. And that's why this is a multi-year roadmap in most cases. This allows you, just like that exponential graph that we looked at in the beginning, by reinvesting year over year into these new technologies and gaining more efficiencies and time, and then reinvesting those efficiencies and time back into the next wave, you're going to get that exponential growth in IT as well. The innovate side is really where you want to get to. And it seems a little academic, but there are technologies on the horizon, things like blockchain, IoT, machine learning, augmented reality, a number of others that today look like future technologies for maybe your business. But if you think about that growth curve again, it could be that in 18 to 24 months, one of these technologies might define your vertical. And if you don't have time to be looking out at what those technologies can do for the business, you may fall behind. And because of that growth curve, catching up is going to be exponentially harder if your competition outpaces you in a significant way. So we feel like this model is the best way to get you to that stage where you're not managing infrastructure and pushing buttons and turning knobs and pulling levers. You're actually helping the business advance their technology to meet the needs of your customers, your employees, and your business partners. So the best way to start is by starting with the business. Never start with the technology at the bottom. This is what I mentioned earlier in the barriers to transformation. But you have to start with the business. Engage business leaders. Find out what's important to the business. Find out what their 3 to 5 year roadmap is. And layer by layer, peel that back into eventually what technology do you need to support the business and those business goals. And from a very practical perspective, again, keeping in mind that this is a 3 to 5 year roadmap, this is basically a kind of a 6-step plan to get you into that self-funded transformation. The first one, as I mentioned a moment ago, was engage the business leadership. The important thing here is be very specific. Don't just say we want to make customers happier. Don't settle for that kind of answer. Settle for whatever KPIs and metrics the business is using to measure those business initiatives. The next thing you need to do is you have to use some type of framework or methodology that allows you to align the business to the technology investments. We at Round Tower use TOGAF. There are a few other ones out there. We can help if you don't have the staff or the knowledge to do this. These are the type of strategic engagements that we're very, very good at. the bottom line here again is not starting with the technology. The third thing is to address your technical debt. This could be part of your modernization roadmap, but the important thing here is that you do not want to carry over technical debt into your modern data center or your cloud computing environment. And in many cases, you simply can't. For example, if you have Windows 2003 or 2008 in your environment, you simply can't run those on a lot of these infrastructures today. They're not supported anymore. So you have to have a plan to address that. The next thing is to create that roadmap for self-funded transformation. This is the output of one of those strategic engagements using a TOGAF framework. The one I showed you a few slides back was more conceptual, but there is going to be one very specific to you and your business, and also from a timeline perspective. If you have the appetite to consume this in a 2-year chunk or a 5-year chunk or maybe a 10 or 15-year chunk, everyone is different. The next thing you have to do is just do it, right? To quote Nike, you've got to take that roadmap, get the budget, and go do it. If you don't have the resources to execute, there are partners like Round Tower that can help you execute that roadmap. And that's where Round Tower shines in comparison to some of our competitors. We not only can create that roadmap and that vision at a very high business strategic level, but we have the resources and the expertise to execute those roadmaps, actually put them into practical use, put hands on keyboard, foot on boots on ground, whatever analogy you want to use. That's the differentiator for Round Tower. And then the last thing is that after you've built a 3 to 5 year roadmap, you can't just set it on a shelf and look at it again at the end of the 3 or 5 years. You have to be very agile in how you execute this roadmap. You have to be willing to make small investments along the way and then pivot if you need to. You need to have KPIs that you're measuring against and tracking against along the way to know if you need to pivot. So it would be much, much better to make a smaller investment in maybe a few thousand or hundreds of thousands of dollars than make a 5-year, multi-million-dollar investment and realize at the end of 5 years that you made the wrong choice. So that's not what we want to do. If you have any other questions, feel free to reach out to me. This is my email address, roundtower.com, and thank you for your time.